We're going to look at the science behind Sputnik's radio communication. The first artificial satellite that gave off a radio signal that made history. And the antennas were relaying signals back to radio operators on Earth. But because of the wavelengths, they were able to be picked up by amateur radio operators. And here's some actually in 1957, and they were listening to Sputnik. And so what were the radio signals that came from Sputnik? First thing is they're wireless communications, and they use electromagnetic waves. And here we have an example of a radio wave, and the lower left you see one wavelength, which is the repeating unit for each of those continuous waves. So the waves are part of the electromagnetic spectrum, but they're the longest waves. Here shown in the box on the right, radio waves, which can be meters, hundreds of meters in length for one wavelength. And the frequency is measured in hertz, and here you've got the equation of F, the frequency, equals c, speed of light, over lambda, the wavelength. So there's a relationship between frequency and wavelength. And if you look at the formula on the far right bottom, the frequency is inversely proportional to the wavelength. And here we've got the two equations written again. And so Sputnik was actually designed to be noticed. Its orbit covered most of the populated Earth. Its radio transmission was accessible by amateur radio enthusiasts over the surface of the globe. And it was shiny. It could be seen. It was small and it was flying high, particularly with binoculars. And so it was the first artificial satellite communicating with Earth. Previously, or following this, we've got modern satellite communication, which uses satellite to relay back to different stations. But the Earth's atmosphere doesn't allow all of the frequencies, wavelengths of the electromagnetic spectrum to pass through Earth's atmosphere. So you've only got the visible region and parts of radio wave region that can pass through Earth's atmosphere. Other wavelengths are absorbed and don't reach the Earth's surface. And Sputnik was able to discover the density of the upper atmosphere by its orbital decay rate, and it was also discovering the effect of the ionosphere on radio signals. So it was an important science experiment of its time. And just here's a slide showing the satellites that are used for the wavelengths that can't pass through the atmosphere. So you launch a satellite which can access those wavelengths and send the information back to Earth. So where was Sputnik's radio transmitter? Here's an expanded view showing the hemispheres that were joined together, the antennas, and the radio transmitter that actually fitted in those blocks, which are the batteries, and a cooling fan beneath it. And here's another diagram to see that expanded view again. The radio signals only started once Sputnik was actually deployed at its altitude, and there was this arming ring that prevented the batteries from setting the radio transmitter working, and there is a replacement version on display at the National Air and Space Museum in Washington, D.C. Now, one thing about sounds is that their pitch varies as they approach you and as they pass. And this is known as the Doppler effect. You may have noticed hearing an ambulance siren, shorter wavelength as it approaches, higher pitch. The departing, receding ambulance, longer wavelength and a lower pitch. The same applies to the satellite, the radio signals from Sputnik. So those amateur radio operators listening on Earth would hear a higher pitch as Sputnik was approaching, and then as it was departing, it would have a lower pitch, longer wavelength with a smaller frequency. And what we can look at here is a little more about the Doppler effect, and the red at the bottom, quite a long one to type in, but you can do Folkways at si.edu, Smithsonian Institute, and then put in Sputnik audio Doppler, and it will come up. And here are the equations. So on the left, you've got the frequency heard by the observer. So an ambulance, or indeed the Sputnik radio signal approaching the observer, is equal to the speed of sound over the speed of sound minus the speed of the approaching object, here the ambulance, multiplied by the siren frequency. So if it's approaching, you've got a minus sign. So the denominator is going to be smaller. And if the denominator is smaller, the frequency that will be heard by the observer is larger. And pause the slide to look at the plus sign and what's happening here. Now, a description of an activity here, to have a radio, preferably a battery radio, and can you block radio signals by any particular materials? The number of layers, what other things would you investigate as you do this? So you can pause here to look at this activity. And here's a summary of what we have with Sputnik's radio transmission, with the electromagnetic spectrum and radio waves, and the Doppler effect, and a picture there of Sputnik being released from the nose cone of the rocket, and the start of the radio signals as it was deployed at altitude. A little bit more about the antennas and the radio signals. 4 antennas, 2 slightly shorter and 2 slightly longer, and they produce a dipole, 2 beams going out in opposite directions, looking at the diagram at the bottom of the arrow there. And Sputnik had 4 antennas to make sure that a signal would reach the Earth's surface, because they didn't know the actual orientation that it would travel. And there were 2 wavelengths, 40 megahertz, 20 megahertz frequencies, and 7.5 and 15 meter wavelengths. So it's a radio transmitter sending an alternating current, and the charge charges them alternately positive and negative. And that is what will produce the radio waves. Just out of interest, astronomical objects with changing magnetic fields produce radio waves. and we have waves on the wind spacecraft recording a day's bursts of radio waves. And you can pause this to see where Jupiter's emissions comes from, and indeed the sun's. And radio telescopes, you've got longer waves than optical waves for the visual light wavelengths, and they're made very differently. And here we've got these large dishes, and in order to be able to see different parts of the universe, there's the Very Large Array made up of 27 dishes that can actually be moved around in a huge pattern, moved on railway lines. And here are some of the images that you might see, and place suggestion where to tour to look at the radio waves. Pause that to look. The second activity here, similar to the radio one, but you can do it with the radio controller of a radio-controlled car, covering that with a different set of materials, including, here we've got a rubber glove that you're putting the material in. And then we've got other things to investigate, so you can pause here if you want to look at modern satellite communication activity from NASA. And a reminder that Sputnik was an important science experiment of its time, discovering the density of the upper atmosphere, how Sputnik decayed after its power systems had failed, and the effect of the ionosphere that it had on the radio signals. And here the red vertical arrow there is the ionosphere, which goes nearly from the surface of the Earth up to the ionosphere, and it's made of electrons and ionized atoms and molecules. And that has a significant effect on the radio transmissions as well, and it varies in thickness and depends on things like solar storms. Now, just looking at the difference between AM and FM radio signals, amplitude modulated on the left, and that's just the height of the waves. The amplitude of the waves will vary with this. And in frequency modulated, it's the numbers of peaks, but the height of the waves is going to be the same, but the frequency is going to vary. And if you look at another version of the electromagnetic spectrum, you can see, if you look carefully in the beige region, the AM and the FM only being very small parts of the entire radio wave bandwidth. And out of interest, you can follow a newsreel that was broadcast on public television in October 1957, just to see what was being broadcast, and an artist impression of Sputnik in orbit. And finally here, just looking at some stamps, one Ukrainian, one from the Soviet Union, USSR, and there are plenty others that you can look at. And the link there, or two links, where you can actually hear the beeps. They're mentioned in several other places on the video here.